Okay, let's continue on. The next method we had to write was to replace all even elements with 0. So let's copy our call block again. And we'll put in a good label. Need a new method name. And then let's start out with print array. We need to go through all of them. And we called it replace even. Okay, so we're looping through all of them beginning to end, and what we want to do is we're checking if the actual item, not the index, the item, so we get the item, when it's divided by 2, is its remainder 0. Okay, and if so, then we're going to replace it with 0. Otherwise, we do nothing. So go through the whole loop with this line here. Check out if it's an even number. If it is, we replace it to 0. Otherwise, we do nothing. And we did our call block below, so let's compile and run. Let's see how that looks. Okay, good. Original, swapped, shift, and here's our even elements replaced. So 10 got replaced, 2, 4, etc. Okay, let me clear that. All right, the next one we needed to do was replace each element except the first and last by the larger of its 2 neighbors. So again, we'll redo our call block. So we're replacing with larger, so replace with larger, we'll call it. You can start out with, that doesn't really matter. We'll grab swap element again. Oh, no, I want the loop, sorry. Replace even. And I called it replace with larger. Okay, so what we're doing here is we're not going to do the first element because there is no left-hand neighbor, and we're not going to do the last element because there is no right-hand neighbor. And then what we need to do is we just need to check which one is larger. So if data sub I minus 1, the left-hand neighbor, is larger than the right-hand neighbor, then I replace data sub I with the larger, which would be correct. So if the left hand is larger than the right hand, then I put the left hand in, else data sub I gets the right hand neighbor because that was the larger one. And if they're equal, it doesn't really matter what happens, so we can just do it this way and it still will work fine. It will still replace. But they're both equal, so it doesn't matter which one replaces. That's done. The call is done. Let's take a look. Good. So, for example, we ignored this one because there was no left-hand neighbor. We looked at 0. The left-hand neighbor was 1. The right-hand neighbor was 0. So the larger was 1. It got replaced. And we continued on through and went all the way through. Okay, let's clear that. We'll do one more in this recording, and then we'll go to a new recording, and I'll close this one out. So the next one we need to do is return true if the array is currently sorted in increasing order. Let's get our call block copied. Put a nice label, is array increasing, and we'll call it check increasing. Whoops. Now we're going to have to go all the way through the array, so let's grab one of our loops. And we called it check increasing. Okay, now this one's going to be a little bit different because we're actually returning a value. We're not making any changes to the array. We just want to know if some state exists in the array. So we're going to return a Boolean if it's increasing all the way through, we will return true, otherwise we'll return false. So we need to check through the whole array, so we need to reset these back to 0 and 10. And what we're going to do is we're going to look for when it's not true. So if, whoops, my next element, so I plus 1, is less than the preceding element, then I failed, right? It's not increasing. And all I have to do in this case is return false and exit the method. As soon as I find an example that doesn't match what I'm looking for, I can stop. I don't have to keep checking the array. And this is the way to do the technique when you're looking for that sort of thing. Especially if some of the arrays you're going to be working with have hundreds and hundreds of elements. So as soon as you find something that negates what you're looking for, just stop and return false. Then you realize if I've gotten all the way through the array and I haven't returned false and I hit this line of code, that means everybody was increasing and I can return true. Okay, so that's all done. The only thing we need to fix here a little bit is our call block here. So I've checked increasing. I'm not going to print the array this time. I want to print this answer, true or false. So you have a couple options here. You can just take this call and put it inside the block and print it like that. This will print. This is going to return a true or false value, so that's what's going to get printed. Another way to do it is remember how you call a method that returns something. You add this left-hand side such that the data type matches what it's returning, and in this case we're returning a Boolean, and then we call the method, so whatever this value that gets returned is going to be stored in the variable answer. And then we can take our print line and we can just print our variable answer. So either of these work fine. Whatever is more understandable and logical to you, you can use. And let's just show you how this runs. Oops, we had a little problem here. Let me just check that. Oh, right. Okay, so this is good to show. So array index out of bounds exception you might get, and it actually gives you the number down here, and in this case it's telling us 10. We went beyond the array. So we're looking for an element at index 10, but our array only goes up to 9. So because we have to check the next element, we can stop one before. We don't have to go all the way through. So let's run that again. Let me just clear this first so it's a clean run. Okay, good. So we have original, everything else is nice. Is the array increasing? Our array currently is increasing, so we get both of our trues printed out. Okay, so I'm going to end this lecture. Let me just clear that and close this out.